Hi everyone, today we're going to be looking at determining the rule of a square root, a truncus, or a hyperbola. Now when it comes to determining the rule of any function, we need at least two pieces of information. Okay, these can be things like coordinates, x or y intercepts, asymptotes, etc. The easiest ones for us to work with these sorts of graphs are going to be things like your asymptotes and your endpoints. And knowing what the letters in each form, like in each function form does to the graph itself is also really helpful because you should be able to just pick things up along the way. Now we want to find the values of a, h and k, which is what we're used to using. H and k, don't forget, is our endpoint, right? So hk is our endpoint. In this case, our endpoint is 2, 4. So our h is equal to 2 and our k is equal to 4. So currently we have y is equal to a times the square root of x minus 2 plus 4. We can then use that second bit of information, the second coordinate, to plug that in and solve for a. So we've got 10 being equal to the square root of 6 minus 2 plus 4. We end up with 6 being 2a, so a is equal to 3. So we end up having the graph here of y equals 3 times x minus 2 plus 4. Okay. Similarly for this one here, you've been given two coordinates, so that means we've got a simultaneous equation to solve here. Okay. I'm going to start by plugging in this first coordinate and then solving for one of my variables just so I can plug that in later, okay? I'm going to choose to solve for k, so I end up with 7 minus a over 2. I'm going to do the same thing for my second coordinate here. I'm going to plug in negative 1, 1. That's going to give me 1 is equal to negative a plus k, so k is equal to 1 plus a. I can now make my two k's equal to each other, so I have 7 minus a on 2 is equal to 1 plus a. We end up with 6 is equal to 3a on 2, so a is equal to 4. Then we plug that into either equation that we have because we should get the same answer realistically. So I'm going to plug that into 1 plus a, just being a bit easier because we know 1 plus 4 is 5. So a equals 4 and k equals 5, okay? Just one last example here because this one is a bit of a trickier example. Is we want to work with the square root graph here. Once again, we're going to have to make simultaneous equations. So equation 1 is going to be 2 is equal to a times the square root of 4 minus h. And if you want to solve for that, you absolutely can, or we can leave it as it is for now, okay? Our second equation is going to be 4 is equal to a square root of 7 minus h. Okay, now unfortunately there is no easy way to go about this one. You do have to solve for one of your variables and then work from there. Now in this case I chose to solve for a, so I have 2 over a, which we end up squaring, is equal to 4 minus h. So h is equal to 4 minus 4 on a squared. Okay, if I then plug that into here, I'm going to end up with 4 equals a times the square root of 7 minus 4 on a squared. And then it's just a bit of rearranging from there. I'm going to end up with 16 on a squared is equal to 7 minus 4, so 3 minus 4 on a squared. It's going to end up giving me, sorry, I believe I've lost negative somewhere, this should be a plus. That will end up giving me 12 on a squared equals 3. So a squared is equal to 4, which means a is equal to 2. And the reason we're going to have just a equal to 2 instead of negative 2 is because we've been told a is greater than 0. Then it's just a matter of plugging that into something we've already got. We know h is equal to 4 minus 4 on a squared. So I get 4 minus 1, which is 3. So a equals 2 and h equals 3.